let's take a look at this hypothesis test problem. The accompanying table gives results from a study of the words spoken in a day by men and women. Use a 0.01 significance level to test the claim that the mean number of words spoken in a day by men is less than that for women. We have our statistics given to us here in this table, the men and the women. And so what we're interested in is testing this claim. So the mean is going to be for men and for women, where it's going to be compared in our claim. So we're going to say that our claim is going to be the mean number of words spoken by men is going to be less than that of the mean number spoken by women. So we're going to use mu for our mean, and mu sub 1 for the mean for the men, and mu sub 2 for the mean for the women. So the opposite is going to be an opposite direction with an equality. More importantly, we want to assign our null and alternative hypothesis. Since this is a statement that does not contain a condition of equality, that will be assigned to mu sub or to h sub 1, our alternative hypothesis. And then our null hypothesis then would be, well, this is one of those cases where you can use an equal to or a greater than or equal to symbol. Doesn't really matter. I think in a real life situation they would rather see the equal sign, but again, it's up to you how you want to bring that up. This is the important part, is that the alternative hypothesis doesn't contain a condition of equality, and in this particular problem, the alternative hypothesis is the claim. Alright, we have our significance level. We are ready to punch this into our calculator. This again is our calculator command little video, and we are comparing two means. Now what's important to note here is that we are given the standard deviation for the sample S. We are not given the standard deviation for a population, and for most cases we will assume that our population standard deviation is not given to us. So in our calculators, we're going to stat and test, and we will select, because our population standard deviation is not given, we will select our t-test. And we are looking at the two sample t-test. So let's go ahead and select that. We have statistics here. We don't have a list of data or anything like that, so we just have plain statistics. And we'll select statistics, and we'll go down and just write them down. We got for the first one 15,688.5 as our mean. A standard deviation is 8632.5. Now for and then we have a sample of 186. Now for women, we have a standard deviation of 16,215 with a 0.0, and our standard deviation is 7,301, 7,301.2, and then our total is 210. There's more information here. we are doing a hypothesis test, so we need to take a look at, in our calculators, we need to take a look at the appropriate alternative hypothesis symbol, and that is the less than sign compared to mu1 and mu2. Mu1 is less than mu2, so we'll go ahead and select that. The pooling, we would be interested in pooling this if we know we have some information about the standard deviations and they're fairly close to each other. Now, since we're not doing a standard deviation test, we're just going to assume for all problems to have our pool to be no. We don't want to pool the standard deviations together, so let's leave that as no. And then we're ready to go. So let's go ahead and run this. And if you scroll down to other pieces of information, you'll see our standard deviation and the sample sizes. That's not too important for us. But what is important are the first two, our test statistic and our p-value. So let's go ahead and copy that, put that in our sheet, and let's focus on what we're going to want to say from here. Okay, so what we're going to say in our paper is that we ran the 2-SAMP t-test, and then we found our test statistic, and using this appropriate symbol that identifies our distribution, we have a t, and that's equal to negative 0.65 or 651. Our p-value, we will call this PV, and that's equal to 0.257258. Okay, so we've stated our hypotheses, our claim and our hypotheses. We got our sample, our test statistic and our p-value, and now we're going to make our conclusion. So since our p-value compared to alpha, so our p-value is 0.258 and our alpha is 0.01, clearly our p-value is bigger than alpha. We will fail to reject our null hypothesis. So we fail to reject our null hypothesis. So this is our decision, and now we're going to write our conclusion. What is our conclusion? Well, let's take a look at this. Our original claim does not contain a condition of equality, and we fail to reject. So those are two things we're going to look for. And I find this table to be really, really helpful. Wording for the final conclusion. The original claim, let's take a look at the first one. The original claim does not contain a condition of equality, and you rejected the null hypothesis. Now, we did not reject the null hypothesis, so let's move on. Original claim does not contain a condition of equality, so we have that, and you fail to reject the null hypothesis, so this is what we're looking for. There is not sufficient evidence to support the claim that. That's what we're going to use. So let's go ahead and begin writing. There is not sufficient sample evidence to support the claim that, and what's the claim? Test the claim. So here's the claim. The mean number of words spoken in a day by men number of words spoken in a day by men is less than that for women. So the safest thing to do is to write exactly what they have written down as their null and or as their claim. So just word for word, the mean number of words spoken in a day by men is less than that for women. Okay, so this is it. This is our conclusion, and that's the end of this problem. Okay, I hope this helps.